Hey guys, so we're going to be talking about a new unit. This unit has to deal with polynomials, exponents. So it's going to be a long unit. It's going to take us for the rest of the 9 weeks, okay? And we're going to start off with exponents. So I'm going to try to zoom in a little bit more on here so we can see it better. Let me see if I can. Zoom right in for 200. There it goes. Okay, so unit 1 is day 1. Unit 7, day 1, sorry. Product, quotient, and zero rule. Our weekly objectives, students will know how the exponent rules are used to simplify expressions, and students will understand that the rules only affect the like or same bases. Students will be able to simplify expressions, fix that real quick, using exponent rules. Okay, so here we go. What is an exponent? So in your own words, I want you to be able to tell me what an exponent is. Okay. Remember that you have either the number right here and then the exponent is up here. So what does that exponent mean? Right. Let me give you an example for you to be able to write it in your own words. So I'm not writing anything in the boxes because this is you in your own words. But if I had 3 squared, then it would be, I would have 3 and 3. I just wanted to use something. Okay. So what is that 3? That's 2 telling us. Okay. The exponent is going to be that smallest number, but what is that number telling us? What does the base tell you? So the base would have been the 3. So let me write it over here. And then I'll get rid of it. But I want y'all to see what I was saying. Make it really big. 3 and insert characters. There it goes. What does that mean? The exponent is that 2 right there. So I want you to tell me what that 2 means. And the base is this 3. What does the base tell me? Okay. What does that tell me? So the green is going to go in here. You're going to tell me what that 2 means. And here you're going to tell me what the 3. You're going to tell me what the exponent is, which one's the base, and then tell me what does that exponent ultimately tell you to do. So the exponent is always going to be that smaller number. The base is going to be what is being raised to that power. And then what does that exponent tell you? Now right here, we're going to try to type it together, and you guys are going to be able to strengthen what you write here, because maybe you don't know what to write in that box yet. But if we did this right here, you would. All right, so I'm going to type it for you. 2 times 2 times 2 times 2. That is what 2 to the 4th is written as. Negative 6. Negative 6. Oh, I'm just going to put without parentheses because I can't. Negative 6. All right, what does that mean? I'm demonstrating to you what it's supposed to show you, but I need you to be able to tell me what it means. Okay, and here, y times y times y times y times y. What does that mean? Okay, what does this mean? Okay. So I showed you what it's supposed to show, but I need you to be able to explain to me what is happening. What is it telling you? Okay, now we're going to go here. Exponents only apply to what they touch. So right here, the exponent is only touching the x. All right, so that means that the x is going to repeat. And I repeat it 1, 2, 3, 4. Here we have parentheses. Because we have parentheses and the exponent touches that parentheses, that means that everything inside that parentheses is going to repeat. So I have 7x, 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 and 7x. Negative 3 squared. The squared is only on the number 3. So only the 3 is going to repeat. The negative does not repeat because it does not have the squared. It does not have the exponent next to it. So we have the example here, negative 3 times 3. Now, the difference between the top one and the bottom one is that the bottom one has parentheses. So when it's in parentheses, the whole entire thing repeats like I told you on this one. So -3 times -3. That's why it's so important that if you are squaring a negative on a calculator that you must put parentheses on it, because if not, the calculator is going to do this part right here, where it's only going to be -3 times 3, and that's not what you want. Now, what is a base? It is the number or the coefficient, so like it could be 7x, or a variable. Okay? So it could be a number, which is just either a coefficient by itself, or it can be a variable, and that is the blank to an exponent. And since we're saying base, we would put base right there. Identify the bases in the problems to the right by placing a circle around it. Okay, so let's see. The x would be it, so I would place my thing in there. My whole entire parentheses, only the 3, and then the whole entire parentheses. Okay? So what we're doing here is that we're going to compare the exponential number to its factors form. So I have 4 squared. That means the factors form, or the expanded form, as I like to call it expanded, is 4 times 4. Multiplied would be 16. All right, 7 to the third would be 7 times 7 times 7, or 343. I just wanted to show y'all the expanded form. All right, so now this is what we have over here. We're matching the exponential form, which is the exponent form, to the expanded form, or the factor form. And you're going to use these lines. Remember, it has parentheses, so it should match up with -3 and -3. So then we would use that and draw the arrow here. Here's the one that has that. This one only has 3a in the parentheses, so 3a would be showing up twice. So then that means this one. And I can shorten it up if I want. Not the one I wanted to do. All right, then -3a squared, only the a should show up twice. And then this one, only the 3 should show up twice. And then this one right here, only the 3 shows up. Okay, all right. Let's go here. Now we're going to match it. You're going to match the exponential form to the expanded form. Okay. This is you on your own. Okay. I'm going to pause it, and I hope that you pause it. Okay. And then try to do this and then come back and see the answers. But I really need you to try to match up what it shows. So right here, the 4 is out there. So that whole -4 is going to be showing up. That's the one that's going to repeat 4 times. The -3x, how many times is it going to repeat? This entire thing is going to repeat. Only the 4 will repeat. Only the 4, only the z, the whole entire thing. The x, only the y, and the whole entire thing. Okay, so I'm going to pause right here, and I hope that you do too, and I need you to match it up. Okay, here are the answers. Okay, so -4, I looked for -4. -x, I looked for -x, repeat 3 times. So here's all my matching. Hopefully you got these right. Okay, and that means that you do understand where the exponent is and who is the one that's going to repeat, and that's very important. All right, let me pause here to get ready for the next slide. Okay, here we go to the next slide. Write each product below in expanded form and then rewrite the product in exponential form with a single base. Okay, so here's the expanded form. I have 4 to the third, so I have 4 right here. And I have 4 to the fifth, so I have 5 4s right there. So I count how many 4. Remember, the exponent is telling me how many times the number is going to repeat. So I figure out 1, 2, 3, 4, 5, 6, 7, 8. So I click on this little box and I put 8 because that is going to be my exponent. We're going to expand this one out. 3 times 3 times 3 times 3, that's 4, times another 2, and then I count how many times do I see the 3. 1, 2, 3, 4, 5, 6. I do the x's. 1, 2, 3, okay, and then 1, 2, 3, 4. All right, how many times do you see it all together? 1, 2, 3, 4, 5, 6, 7. That's the exponent that I put right here. 10, 3 times 2, 2, 3, 4, 5, 6. Now I count the number of times I see 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's okay. My Y went down, so I got to put it down here. Right? 1, 1, 2, 3, 4, 5. All right. So you count 1, 2, 3, 4, 5, 6. So that's how many I see right here. Right. So it says compare the exponents in each of the final expressions to the exponents in the original product. Describe a way to find the exponents in the final expression without using the expanded form. So how could we have bypassed this? 3, 5, and then it became 8. 4, 2, and then it became 6. 3, 4, and it became 7. 3, 6, and it became 9. And here I know that you don't see an exponent, but anything that's just there has an exponent of 1. Remember, the exponent says how many times you see this. How many times am I going to see that variable? How many times am I going to repeat the variable or repeat the number? So if it has a 1, that means it's only repeating 1. Okay, 1 time. A 5 means it repeats 5 times. Right? So anytime you see a variable or a number by itself and you think it doesn't have an exponent, it does. The exponent would be 1. Right? Because you see it. If you didn't see it, it wouldn't be there. Okay. So when multiplying bases that are the same, because all of these have the same base, you blank the exponents. This is called the blank. So let's see what it says. It says that you add the exponents. Well, let's see if that's true. 3 plus 5, that equals 8. 4 plus 2, that does equal 6. 3 plus 4 does equal 7. 3 plus 6 does equal 9. And then 1 plus 5 equals 6. So yes, this is true. This is called the product rule. Okay? This is what we're going to be practicing for the next couple of slides. Okay, so on here we're going to fill in the missing box with the correct exponent. So again, remember you're adding. So you're adding 4 plus 6. Okay, add those two numbers together. And that's what you're going to put in here. What's 4 plus 6? What's 9 plus 2? Notice that on this one there's a coefficient. The coefficient doesn't have an exponent. There is no other 3 on here, or there is no other number in front of this n. So we're just going to leave the 3. We're just going to add the exponents. 3 plus 7. And over here, you're going to bring the 2 down because there's nothing else in front of this first n. And you're going to add the exponents because you're adding the ones that are the same base. Okay, so remember, add. I'm going to pause it here and then come back and you'll see the numbers. All right, here you go. All right, these are all we did was just add. All right, so let's go to the next slide and read what's going on there. Okay, so what do you notice that I did when I have two coefficients? So what I'm doing here is I'm expanding it out so that we can see it. 2 times 3 because they're coefficients, they're the same. Okay? And then k to the 11th. Okay? I can't do anything to these because they're coefficients. They're the same thing, but they're not the same number. So I can't add exponents for those because they're two different numbers. So what I'm going to do is I'm just going to multiply them. Okay? And I get 6. Okay? And then k to the 11th. So we're going to do the same thing with the next one. 5 times 3 is 15. And then I'm going to add the exponents for a, which is 2 plus 5. That's 7. I'm going to add the exponents for b, 3 plus 2, and that's 5. And then I put all of it together, the 15, the a, and the b. And so now we're going to practice with this. Okay. I'm going to pause and then come back, and hopefully you got this done. Okay, so here it is. We did 4 times 2. That gives me 8. That's why there's an 8 in this box. 6 plus 1 is 7. 5 times 4 is 20, and then 5 plus 2 is 7. Remember, we're only adding the exponents, and the other coefficients we're just going to multiply, because that's what this operation right here in the middle is saying, multiply. 8 times 6, I don't know why I put 18, but we all know that should be 48. 3 plus 5 is 8. 7 times 3 is 21, and 5 plus 6 is 11. Okay? All right. Let's see. The next one has more than one variable. So what do you think you're going to have to do because it has more than one variable? You're going to do it like how we did on slide 9. You're going to add the exponents for just the A, add the exponents for just the B. So you're going to take each base separately and add their exponents. You can't add them all together because they're not the same base. You can only add the exponents for the bases that are the same. So for the R, you're going to add those exponents and put it here. For the S, you're going to add the exponents of the S. And so we're going to do add the exponents for the T, add the exponents for the U. Separately, you cannot combine them two because they're two different letters. They're two different variables. Okay, so I'm going to pause here, and then hopefully you can try to do this on your own. And then when you come back, you'll see what the answers are. Okay, here are the answers. Remember, we're just adding the exponents. Miss J added it incorrectly right here. Because what should this be? 4 plus 2 should be 6. 7 plus 4 should be 11. I don't know where I got that number from. Oof. Okay, so let's check these. 6 plus 1 is 7. 2 plus 3 is 5. 1 plus 7 is 8. 5 plus 1 is 6. 1 plus 2 is 3. 6 plus 3 is 9. And all I did was bring the 8 down because I didn't have anything else to multiply it to. 5 comes down. There's nothing else to multiply it to. 4 plus 2 is 6. 7 plus 4 is 11. Okay. All right, so that's enough with the product rule. We're going to go on to the quotient rule. We're going to do exactly what we did on slide 7. We're going to expand it and figure out what is the pattern that's going on. Okay, so rewrite each quotient below in the expanded form. Then rewrite the quotient in exponential form with the single bases. Okay, so here's the expanded form. Now, what you were taught in middle school was that anytime you have the same thing at the top and the bottom of a division line, then you can cross it out. So I have 2 and 2, so I'm going to cross that out. Use a different color so we can see it. What about this light blue, and then make it a little bit like that. All right. And then we have another 2 by 2, another 2 on the top and the bottom, and then another 2 and the 2 at the bottom. Okay, so that right there is telling me how many 2s I have left over. 2. All right, we're going to do this one right here. 4. Oh, sorry, that's the subtraction. That's 3, 4, and 5 at the top. And underneath I have 1. Right? I'm hoping that's 1. Okay, I'm going to use this right here. And I'm going to subtract, cross those out because those are going to go away. And I have 1, 2, 3, 4 left over. Okay, this one has 9. 2, 3, 4, 5, 6, 7, 8, 9. A little bit over. It's not gonna let me. Okay, so what I need to do is make this smaller so it'll fit. It goes, underline it, and then at the bottom it needs 3. We're going to use these to cross out the ones that I have. I have 1, 2, 3, 4, 5, 6 left. Okay, so what could I have done? It says compare the exponents to each final expression to the exponents in the original quotient. Describe a way to find the exponents in the final expression without using expanded form. 4 and 3. How can I get 2? Subtract. Let's see. Dividing the bases that are the same, you would subtract. Yes. So 5 minus 3, and it's always the top minus the bottom. The top number minus the bottom, okay? So 5 minus 3 is 2. 5 minus 1 is 4. 9 minus 3 is 6. So you're always doing the top number to the bottom. And this is called the quotient rule. Okay, so we're going to go down to the next slide and we're going to practice. Okay, so here we are. We're going to practice. You're doing 13 minus 4. That is 9. 8 minus 3, 5. 9 minus 4, 5. 5 minus 4 is 1. Now you can have that one there, or you usually don't write it when it has an exponent of 1. But for right now, because we're practicing, we're going to write it. Okay, now we're going to do the same thing over here. Just like how we did on the last one, the bases that are the same, you're going to do them separately. We're not going to combine their exponents and then subtract. No, we're subtracting the r's. Then we're subtracting the s's. So 8 minus 1 is 7. 3 minus 1 is 2. Remember, always the top minus the bottom. Now, when we have coefficients, we actually do the quotient. Quotient means to divide, so that means I would divide 15 by 3. And then I subtract the exponent. 3 minus 2 is 1. All right. Okay, so let me pause there, and then let's take a breather, a little mental break right now, and we're going to go on to the last rule for the day. So hopefully you took a little mental breather, just relax for a little bit and be like, all right, I had 2 exponent rules. I took that into my brain. Like, let's make room for one more. You're just using the regular calculator. So I'm going to get this calculator out. And it's on scientific, which is fine. So we do 5, xy, 0, 1. All right, that's what we do on that calculator. Let's do the practice Desmos. Okay, 5. You hit the shift and the little and shift and 6, and you put 0. That's 1. Then we do 100. Shift 6, 0. It's also 1. 1 half, and then the 0. 1 half. The parentheses. 0. 1. And then it said negative 20. This is a negative 1. So all the other ones were giving me 1s, but this one gave me negative 1 because the 20 is the only one that's getting raised to 0. The negative sign isn't. So when I get that 1, I have to bring that minus sign, the negative sign next to it. All right, so we put 1, 1, 1, and negative 1. All right, so right here, I want you to tell me what's your exponent here and what's the exponent here. Remember, here you're subtracting. Here you're adding. 5 minus 5 is going to be 0. 6 plus negative 6 is going to be 0. And then this gives you a 1. No manches. Sorry. I was just trying to get it clean for you guys. Okay, so now you're just going to go on to your practice. You're going to work on it with a partner, group, or individually. You know, if you're online, then you're probably doing that on your own. But if you're in class, you're doing it with a partner and a group. Okay? All right. We'll see you next time on the next day, Unit 7, Day 2.